Makino has developed a new pallet system concept called the work-holding pallet system. This system enables smart workpiece setups suitable for multi-face machining. A horizontal machining center serves as the core machine. The first machine pallet has a 4-axis specification. There is another 5-axis specification created by adding a rotary table. This combined use of 2 different tables achieves highly flexible operation. One of the strong points of a horizontal machining center is that chips naturally fall down below. The machine design is advantageous to unmanned operation because it avoids the problem of chips getting caught in the spindle taper. Makino developed the work-holding pallet system to facilitate efficient multi-face machining in one chucking operation on 5-axis horizontal machining centers. Work-holding pallets, 30 millimeters in thickness, are available in 2 sizes, 400 by 400 millimeters and 400 by 500 millimeters. The pallet is provided with multiple holes for attaching the workpiece or a jig plate. The underside of the pallet has 2 pull stud bolts for attaching the pallet to the rotary table or to an angle plate. The workpiece is attached to the pallet by bolts that are inserted through the holes from the underside of the pallet. As shown here, the pull stud bolts have a reference line that can be used for positioning to achieve repeatability within plus or minus 2 microns. With a total clamping force of 30 kilonewtons, the pallet is designed to withstand even heavy-duty cutting operations. The work-holding pallet system minimizes the use of clampers and vices to hold the workpiece. This fixturing approach avoids creating areas where interference might occur and enables multiple faces to be machined in one chucking operation. An air vacuum circuit is available as an option for holding a thin plate-like workpiece using a vacuum chuck. We have just seen the major features of the work-holding pallet system. In this first process, the workpiece is rough machined using an angle plate. Then, in the second process, the rotary table is used to execute 5-axis finish machining. This combined use of 2 different tables allows highly flexible operation. Combining a robot with the work-holding pallet system facilitates continuous unmanned operation. Because the robot's hand can grasp the pallet, there is no need to have robot hands that match different workpiece sizes or shapes. One hand alone can handle a wide variety of workpieces. The work-holding pallet system flexibly accommodates high-mix, low-volume production, as well as production involving variable varieties and volumes. What is more, in tandem with a robot, it also facilitates continuous unmanned operation at night and on weekends. Aikoku Alpha Corporation is one of Makino's customers located in Inazawa in Aichi Prefecture. Aikoku Alpha was established in 1943, and all of the employees take part in managing the company. Aikoku Alpha has continued to grow over the years under a corporate culture in which the company and the employees respect each other as valuable partners. The company's main business activities include the manufacture of automobile and aerospace components, the manufacture and sale of hand cranes, and the development and sale of CAD/CAM software. Aikoku Alpha has an excellent reputation among the world's leading automakers and aircraft manufacturers for its advanced technological capabilities in such areas as cold forming and simultaneous 5-axis machining. Their Aero and Precision division that machines aircraft parts recently installed a work-holding pallet system. Let's take a look at their system. The system they installed consists of two a61 FXR 5-axis horizontal machining centers, one self-propelled transfer robot, two work-setting stations, and a 45-piece pallet stocker. Now let's look at the flow of work operations. The workpiece is set up at the work-setting station. As you can see, the workpiece is set up horizontally, which reduces the operator's workload. Once the workpiece is set up, the machining schedule is created using Makino's a61 system control software. Scheduling, program editing, tool data management, machining results tabulation, and other tasks are all performed on the host computer. The input workpieces are transferred from the work-setting station to the pallet stocker and wait their turn to be machined. The self-propelled robot places a pallet on the stand and moves to the next position. The stocker can hold 45 work-holding pallets positioned at a slant. Slanting the pallets make it easier to collect the coolant, and it also saves space. The robot's hand is fitted with a sensor for detecting the presence of a pallet before the robot moves. After machining is finished, the workpiece and pallet are air cleaned with a cleaning tool. This prevents problems in advance by minimizing the amount of chips and coolant taken out of the machine. The machined workpiece is then unloaded from the machine. The pallet is first moved to the stand, and the next pallet is then loaded on the machining center. Before being loaded on the machine, the pull stud bolts on the underside of the pallet and the seating surface are air cleaned to prevent chip incursion. The work-holding pallet system can accommodate from 1 to 4 machining centers. By combining the system with a robot and hand, a modularized pallet stocker, and a work-setting station, the optimum cell can be configured to meet various production needs. The work-holding pallet system is the optimum pallet technology for efficient operation of a 5-axis machining center. Combining the system with a robot facilitates continuous unmanned operation at night and on weekends. It is the optimum system for high-mix, low-volume production of prototype parts and die and mold parts, for use in production cells, to manufacture aerospace parts and machine parts, and also for producing medium-sized runs of auto parts.